look at our warm-up here. So we have, again, remember, we have our test next class. And it's over our 2 days of quadratics, so graphing quadratics as well as quadratic formula. And then our pre-geometry stuff, Pythagorean theorem, distance, and midpoint formulas. Remember, you have to have your distance formula, midpoint formula, and Pythagorean theorem memorized, but the quadratic formula will be given to you. You will need to have that eventually memorized for next year, though. Okay? But it's expected that you have Pythagorean theorem, distance, and midpoint memorized. So actually, let's go ahead and go over that right now.
Oh, do you have any of them? We should have them at least to start on because the test.
All right, let's start off with what's probably the easiest one. Yes?
You can say.
Oh, I was going to go Pythagorean.
Oh, okay.
What's Pythagorean theorem? Good. A squared plus b squared equals c squared. Good. And when do we use the Pythagorean theorem? Right, when we're dealing with right triangles. And we're dealing with the sides of a right triangle. Good. What do A and B represent? What are A and B in my Pythagorean theorem? The sides, yeah, the legs here. And who remembers what the name is for C? Hypotenuse, good. And that's the one that's always opposite of your right angle. So your A and B are going to be the two smaller numbers. If they give you 3, your two smaller numbers, and C is always your largest of the 3. Okay, let's do distance next. So distance, I think, is kind of the most complicated of all. Go ahead, Gabby. Good, square root. Good. X minus X. Awesome. Good. Awesome. Very good job, Gabby. So our distance formula is subtracting your x's. Take that and square it. Subtract your y's. Take that and square it. Add those together, take the square of the whole thing. So that's what I think is kind of the most complicated. It's kind of similar to our slope formula in that we're subtracting our x's and subtracting our y's. Make sure you don't forget your squaring. Like I said, on your test, you will have a question that says, what is the distance formula? Right there, I already told you a question for your test. So make sure you have that memorized for next class. Alright, then midpoint is our last one. And remember, a midpoint is just an ordered pair. You know this one too, Gabby?
Yeah.
Okay.
So, X plus
Good.
over 2.
Awesome. Awesome. So you add your x's and divide by 2, add your y's and divide by 2, and that's your midpoint formula. So remember, it's just the average of each one. It's the halfway point. So you add them and divide by 2. Halfway, you divide by 2. Very good. Alright, so again, you have to have these memorized by next class, because for the test, you won't be getting these. Alright, so looking at our warm-up now.
Is there anyone that doesn't have their homework stamp? That has it? Is there anyone that needs a calculator that doesn't have a calculator?
Okay, so on your warm-up, you're supposed to do number 13 and 17. We're just going to do a glimpse practice of each of these and a little bit with our quadratics. All right, number 13. The instructions said to find the missing length of the right triangle if A and B are the legs and C is the hypotenuse. So we're going to use Pythagorean theorem. A squared plus B squared equals C squared. They gave us A as 11. They give us B. No, so we have to solve for it. And they gave us C. Make sure you don't forget your squares. Okay, what's 11 squared give us? Very good, 121. And 13 squared? Awesome. So now what do I do to solve for B? Very good, subtract my 121. Get B squared equals 48, good. And now what? Very good, Rachel. Square root both sides. So I get B equals the square root of 48. But am I done?
No.
No, we know how to simplify radicals. We've got to simplify this. So let's. Yes, we do, Drew. It's necessary. Alright, so we have to do our factor ladder. Alright, so 48 divided by 2 gives me 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. Divided by 3 is 1. Alright, square root, groups of 2. Group of 2. Group of 2. Any others? Nope. So anything that's a group comes out in front. Remember, this is all multiplication. So group of 2 comes out in front. Times another group of 2, that comes out in front, times, anything else that can come out in front?
No.
Nope. So what's left underneath?
3.
Good, 3. So simplify this some more, and we get B equals 4 root 3. And that's what you get. So really, the only thing new is just remembering your Pythagorean theorem. Because you've already solved for a value squared before, and you've already simplified radicals. So just start off with that a squared plus b squared equals c squared. I remember Mrs. McClellan teaching me that. She loved Elvis, and she thought he was still alive.
How old is this?
Probably about 60. She was fun though. Right. Any questions on that Pythagorean theorem? Okay. So next we have determine whether the given lengths are sides of a right triangle. Again, we're dealing with sides of a right triangle. So what are we going to use? Pythagorean theorem. Thank you, Mr. Pythagoras, for discovering that for us. So a squared plus b squared equals c squared. Again, your a and b are going to be the two smaller values. So we'll let a be 6, b be 9, and c should always be your largest, so c will be 12. So we're checking to see if this is true, because this is only true for right triangles. So to know whether or not it's a right triangle, this has to be true. Alright, so 6 squared, 9 squared, 12 squared. What is 6 squared? 9 squared? 12 squared? Awesome. What is 36 plus 81? 117. Are those equal? Nope. Not equal, not equal, not equal. So what's our conclusion then?
Not equal.
No, not a right triangle. Remember, you need to make a conclusion. That's great if you identify these are not equal, but I need to know that you understand that means it's not a right triangle. So no, not a right triangle. Not a right triangle. And you need to show both the work as well as your answer. You need to be seeing your work problems. Okay. Any questions on that one? So again, right triangles, we're dealing with Pythagorean theorem. Okay. Now on the back side, you're supposed to have done number 4 and number 24. So start off with 4. Alright, our instruction said to find the distance between the 2 points. Distance is the same thing as finding the length. If I find the distance between me and Natalie, the length between us two. Leave the answer in simplest radical form, then round to the 100th if necessary. Right. So our distance formula again, kind of similar to our slope, in that we subtract our x's, squared, and subtract our y's, squared, add them together, take the square root. Okay, so let's set this up. Square root. A big mistake a lot of students make is they forget your square root, so make sure you don't lose that. Square root of x minus x, negative 2 minus 5, close your parentheses, square root, plus negative 3 minus a negative 4. Be very careful as you're dealing with negatives. It's something we've struggled with all year. So be very careful and pay close attention to that. All right. Questions on how we set this up? Okay. So now we just simplify. You've simplified radicals. Negative 2 minus 5 gives negative 7, which we need to keep that in parentheses. And we square it, because negative squared gives us a positive value. Alright, what happens here? Right, a minus and negative becomes plus a positive. So negative 3 plus 4. It's going to give me a positive 1. Positive 1, good. Square. Okay. What's negative 7 squared? Very good. So again, don't lose your square root. And what's 1 squared? And 49 plus 1? Good. So square root of 50. But again, we need to see if we can break this down. Divide by 2. 25. Just divisible by 5. 1. Group of 2. And that comes out in front. Nothing else can come out in front, so the 2 stays underneath, and this is my distance, 5 root 2. Again, we need to see your setup and the work with your final answer. We need to see your work for all these. You will lose points if you don't have work. All right, any questions on that one? Okay. And then finally, we have a midpoint here. Find the midpoint between 2 points. And our midpoint formula is we're just finding the average of our x's and the average of our y's. It's the halfway point between them. Okay? So we have midpoint equals, and it's an ordered pair, it's a point, so you should have your final answer as a point. All right, x plus x, negative 4 plus 14 divided by 2. And my y's, negative 8 plus 6 divided by 2. Then divide by 2. Make sure if you're using your calculator for this, that you put parentheses around the top. You don't want to just type in negative 4 plus 14 divided by 2. You'd have to have parentheses around your numerator. Alright, what's negative 14 plus 4? Sorry, negative 4 plus 14. 10 divided by 2. And negative 8 plus 6? Okay, negative 2 divided by 2. So good, this is negative 1. What's 10 divided by 2? Very good. So my midpoint is 5, negative 1. And we're done. And a way you can check this, again, just do a rough sketch of this. You want to double check your answers. We have point negative 4, negative 8. We have the point 14, 6. Which is approximately over here. And my midpoint was 5, negative 1. It looks like it's about halfway. Again, it's a rough sketch, but it's a good way to check to make sure that your point's not way off. Alright, any questions on that one? Okay. So now let's go ahead and do a little bit with quadratic formula and graph the quadratic. And with that, we're actually going to use the whiteboards because they have a graph on the back of it.
Yeah.
Alright, so we'll done this a little bit. So come on up and grab a whiteboard marker, and a rag to clean it with. Socks. Okay, so again, we're solving this using quadratic formula. Make sure you identify A, B, and C, and then just substitute it in. Alright, so those of you that are stuck as to how to start it, notice in your formula, we have B, we have A, and we have C. So we need to know what those are. Anybody know which one's A, which one's B, which one's C?
Yeah.
Aubrey, give me A. Good. Natalie, give me B.
3.
Good.
Negative.
And what is C?
Negative 2.
-2. Good. So remember, it always needs to be in standard form before you start. And standard form is ax squared plus bx plus c equals 0. So your a value is what's your leading coefficient for x squared, b is your coefficient for x, and c is your resistance. So all you have to do is simply put this into your formula. X equals the opposite of b. This is positive 3, so the opposite would be negative 3. Jason. Plus or minus the square root b squared. Make sure you put it in parentheses. So 3 squared minus 4 times a, which is 2, times c, which is negative 2. That's all under your square root. And the whole thing is over 2 times a, which is 2. So you need to simplify the whole thing. That is beautiful what I have done here. I have no idea. I've never had to deal with it before. Alright, so again, you should have gotten answers of -2 and 1/2. You guys are really, those of you that I saw and were working with, you were definitely on the right track. Alright, no, you were like, I told you, you were one step from the end. You were super close. You were like literally one step from the end, Gabby. You were doing good. Alright, so again, you can use your calculator to help you out, but don't do too much in it because you're going to get lost with your parentheses. So we need to first simplify what's underneath my radical. Alright? So as we go through and do this, so -3 plus or minus, common things I see. People lose their negative in front of their 3. Another common thing is people lose their plus or minus, they think it's multiplication. And another common thing is that you guys start losing your division, you think it's only over here. But in fact, it's the whole thing divided by that. Okay, so don't lose that as well. Those are the things that are often lost. Alright. 3 squared gives me 9. -4 times 2 times -2 gives me a positive 16. Because -4 times 2 is -8 times -2 is positive 16. Alright, what's 9 plus 16? So again, we're simplifying here, not losing any of my pieces. Some of you guys want to get to the end so quickly that you lose a piece. Be careful. Alright, now we can keep simplifying from here. What's the square root of 25? Yeah, 5. So instead of square root of 25, we know that's actually 5. Okay. Now this is just one step from our answers. We should expect to get 2 answers here because we have a plus and minus. So let's first do our plus. -3 plus 5 over 4 and -3 minus 5 over 4. Alright, -3 plus 5? Good. And what's 2 over 4? 1/2. Positive. Negative 3 minus 5? Negative 8. And negative 8 over 4?
Negative 2 over 1.
Which is just negative 2. Okay, so these are my two answers. 1/2 and negative 2. Now when we write this out, don't use ordered pair like that because it's going to look like a point on your graph. When we're listing, we use set notation. So small to largest, negative 2, 1/2. Honestly though, I'm fine if you just box your answers. I'm not going to make you rewrite it like this if you want. Okay. So again, don't lose your plus or minus. Don't lose your radical. Don't lose your division. The whole thing's over. Questions on that? Okay, let's do another one. Let's see. Which one do you want? I'm going to rewrite the quadratic formula. Opposite b plus or minus square root of b squared minus 4ac all over. Okay. All right, solve this one. X squared minus 9 equals 6x. Alright, before you get too far, I want to make sure we all did the correct first step. What format does this need to be in before we can start? Good, standard form. It needs to be in this format, ax squared plus bx plus c. Alright, and how can I get that in that format?
Minus 8.
Good, subtract 6x. Now can I combine 6x with anything on the left? No, none of them are like terms. So we get in that order, 2x squared minus 6x minus 9 equals 0. Now you can continue from there. A is 2, B is negative 6, C is negative 9. So this one, you end up having a radical left in your answer. Remember, we want to keep a radical. We don't want decimals, we want to keep a radical. So we're going to have a radical left in our answer in the end, and you have to simplify completely, all right? So some of you guys were super close to the end there, and you're just a couple steps away. So let's go through this together. Oh, it's still frozen. Hold on. Are you with us, Jason? Alright. So let's set up our quadratic formula. You guys were doing much better with this time. So opposite b is positive 6 plus or minus the square root. Be careful still to use parentheses, negative 6 squared minus 4 times a, which is 2, times c, which is negative 9. All over 2 times a. Now again, if you want to use the calculator to help you out in simplifying, use your calculator, punch this in it, and that's probably the most complicated part of the simplifying there. Okay? So we have 6 plus or minus, okay, negative 6 squared gives us? Good, positive 36. Negative 4 times 2 is negative 8. And negative 8 times negative 9? Good, positive 72. What's 2 times 2?
4.
Awesome. Alright, so we continue from here. When we simplify the inside of our radical, 36 plus 72? 108, good. Over 4. Now we have that radical, so we know if you punch on your calculator, it's not perfect like our square 25 was. So we've got to break it down. We want simplest radical form because that will give us the exact answers. We don't want decimals. All right, let's break it down. 108 divided by 2 gives us 54. Divided by 2 gives us 27. Can we divide 27 by 2? No, so try 3. And that gives us 9. Divided by 3 gives us 3. Divided by 3 gives us 1. Jason and Andrew, are you with me?
That already stopped dancing.
You gonna dance for us? Okay. You wanna do your little touchdown dance? Okay. Alright, so square roots, we have to have 2 of a kind. I see a group of 2s, a group of 3s. Anything else?
No.
Okay. So if it's circled, we bring it out to 2 times 3 times anything else to come out in front. Can't bring anything else, so square root of what's left behind is 3. So it gives us 6 root 3. Alright. So 108 simplifies down to just 6 root 3, so I'm putting that in for there. Okay, so 6 plus or minus 6 root 3 over 4. Now, you so want to be done at this point, but we have one more thing to do. We have to simplify it with our heart. So we simplify 6 and 4, and we simplify only what's in front of your radical. Radicals are kind of testy. They only can simplify with radicals of their own kind. Alright, so then we get x equals 6 over 4 reduces down to
So,
3 over 2. No? 3 over 2. 3 halves. Plus or minus, and 6 over 4 are going to reduce down to 3 halves. Or the preferred way to write it, since they're the same denominator, would be 3 plus or minus 3 root 3 over 2. Either way is acceptable. And then you're finally done.
Math miss.
Oh, it's 2:40, Natalie.
You should take a break.
Alright, any questions on that? Okay, so now we're going to take a look at our graphing quadratics. It's been a couple days since we've done that. So your next question I want you to write on your board is, what is the midpoint formula? What is the midpoint formula?
I was gonna remember.
You can do it. Do your best to remember it. Midpoint formula. Hold on, don't show me yet. I need to finish writing this down.
Oh, Royce doesn't count for you looking at his paper.
Or did you look at your paper again?
He just flipped it over.
I heard shuffling of papers. Alright, midpoint formula. Don't forget our parentheses. Good. Write it as an ordered pair, Jason. Good, Rachel, but be careful because those look like exponents. So write them at the bottom so they're not exponents. Beautiful. Good, but make sure I don't see a plus sign in between, so we're adding between. Write it as an ordered pair. There's somewhere that I need to see. Drew, did I see you?
Yeah.
I did. I don't remember seeing it. No squares. So midpoint is your probably more simple one. Medium difficulty. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. If you're struggling to remember these, my recommendation is just to write it over and over and over again, or make a flashcard and recite it to yourself. Those are the things that help me memorize stuff. These are things that you just actually need to commit to memory and memorize. There's not much in math we ask you to memorize. We want you to understand the process. But these are forms where you need to just memorize it. I can derive it for you, but I think for you guys it might be simplest just to memorize it. Okay, so flip your boards over. There's a graph on the back side. We're going to use that for graphing quadratics. Okay, this guy here. You might need to go back and forth if you need to write work on the front, but your final answer will be graphed on the back. Okay. So our next one, I want you to graph the kind of easier one. Graph y equals x squared minus 6x plus 9. Now, I'm going to go ahead and walk with you guys through the first beginning part in case you have forgotten about it. Okay, so we need to, again, make sure it's always in standard form, which we already have here. And let's identify our A, B, and C. What is A? Good, 1, the leading coefficient. B would be -6, and C is 10. Now, our parabola we know looks something like this. We need to have our vertex, and then some points to be able to graph it, right? So we need to start off finding our vertex. Your vertex is, we want to first find -b/2a. That'll give us both the x value of a vertex as well as that axis of symmetry. So -b/2a. Well, what's the opposite of b? Good. And 2 times 1, so that's 6/2, which is, as we just said, 3. So of my vertex, I have 3. I also have my axis of symmetry is x equals 2. So why don't we go ahead and draw our axis of symmetry? Always a dotted line. That's not actually part of our graph, it's just reference to help us better graph. So go ahead on the back side of your graph, draw on your dotted line of x equals 3. Another one. Here, I'll give you mine. Let's see what. Okay. Now that I have my x value, what do I do to find y?
Minus.
Do what? Plug it in, right? This is my x value, so I just simply put it in for x. We can use our calculators for this. Remember, we used the store button to help us out. Or you can just type it in. I'm going to go and pull up my calculator and do store button to remind you guys how to do that. While we're waiting for that, what we're doing is y equals, so we want our y, taking our x and putting it in. 3 squared minus 6 times 3 plus 10. Remember, we can use that store button in our calculator. I want to take 3 and store it in for x. And I'm just going to type out my equation here. X squared minus 6x plus 10. I get 1. So I know my y value is 1. All right, I have my vertex.
1. And then you fold it.
So 3, 1. Go for 3, 1. Boom. Right there. Is this going to open up or down? Up. Good. Because it's a positive leading coefficient. All right. So now we just need to pick some points to the left and some points to the right. So my vertex, I'm going to go and draw my table here. My vertex was 3, 1. I need to pick 2 before and 2 after. Alright, so I'm going to go with 3, 2, 1, 3, 4, 5. Because again, as long as you put your vertex in the middle, you should see that symmetry. Okay. So we need, it's going to start with 1, then we'll do 2. We do our store again. Or you can just punch it into your calculator, but I like that store button. Alright, so 1 stored for x. And I think we had told you guys about this. Some of you are able to just push up on the arrow and select what's above. Some of you are able to do that. But a lot of the calculators, mine, included the one that I personally have, doesn't allow that. But what we can do is hit second enter, and that'll give me what I just typed in. Well, I want something even earlier, so I do it again. Second enter, and that gives me my equation. That way you don't have to keep typing it over and over and over again. Okay. Did you guys get 5?
Yeah.
Awesome. Okay, so the same thing with 2. 2 stored to x. again, I want to get, look, second enter. You'll see in second enter above it, it says entry. So you're just choosing it for entry. And that gives me 2. Did you guys also get 2? Okay. Now I should expect to find it mimics it on the other side. Do not just assume that though. We want to actually double check and see. Because you might have entered to your calculator and you don't want to get the full thing. Okay, so we take 4, store it in for x. It's just a good way to double check that you're doing it right. Good, we got 2. And we take 5 and store it in. Awesome. So after you found your values, as long as your vertex is in the middle, you should see this mirror image. Okay. So now all we have to do is plot this. So we have 0.15 over 1 up 1, 2, 3, 4, 5. 0.22 over 2 up 2. And again, we should see that mirror image. 3, 1, which we already have graphed. 4, 2. 1, 2, 3, 4, 2. Again, it's mirrored away from your axis symmetry. And 5, 5. 5, 1, 2, 3, 4, 5. And again, we see it's 2 away, 2 away, 1 away. Another thing you could do to add to your graph, it is not required by any means, but it might be helpful in making sure you have it located correctly. Is your C value here? This is your C value. That is also, does anyone remember what that is on your graph? No? If I put 0 in for x, that would be starting here at the origin, right? If I put 0 in for x, what would I get? What would my result be? 10, yeah, 10. This actually ends up being your y-intercept. So if I put 0 in, then I get the point 0, 10. And when I graph that, that is my y-intercept. So you actually get another one. Here's your next point if you were to continue on. Again, not necessary, but at least helps you know that you're headed in the right direction. So that ends up being your y-intercept. Alright, any questions on that? And remember, you have your calculator. So punch this equation into y equals and make sure that your graph matches up with it. Again, we'll need to see your work of finding your axis of symmetry and your vertex and choosing your points. But use that calculator check to make sure you did it right. That way you don't have to get it wrong on the test. Alright, any questions on that one? Okay. So now I'm going to have you do one on your own now that we've walked through it. Let's go for... y equals... Actually, you know what? Start off in a different way. Negative 5
That's horrible.
equals x squared plus 6x. So go and write that one down. What format does it need to be in before we start any of this?
Standard.
Standard form. It needs to be in standard form. ax squared plus bx plus c. So what do I need to do to get it in standard form? Good. So here, instead of putting it in y equals format, they put it in this format. That's fine. Just make sure you have it in standard form before you continue. Everything else stays the same. A is 1, B is 6, and B looks like 6. And C is 5. So then continue from there. So go ahead and give that one a shot. We'll give you a good chunk of time to get started on this. And we'll come back together and go over and make sure you're doing it right. So remember, we start with opposite b over 2a. It's our x value or vertex, and it's our line of symmetry. So opposite b over 2a. That's just the first part of your quadratic formula, right? If you look here, quadratic formula, opposite b over 2a, and you're given your quadratic formula, so I can help you out there. Okay, so opposite of 6 would be negative 6 over 2 times 1, which gives me negative 3. All right, so that's my axis of symmetry. Draw that in. Oops. Okay. And take negative 3 and put it back in. What do we get for our answer when we take negative 3 and put it back in? 4?
-4.
Negative 4. Negative 4. So make sure you either store a negative 3 or use parentheses when you put it back into this here. Alright, so negative 4. This is my vertex. We go ahead and plot that. Negative 3, negative 4. And then let's set up our table. Negative 3, negative 4. 2 directly before, 2 directly afterwards. So let's do negative 4, negative 5, negative 2, and 1. Okay. So when I punch in negative 4, you should get negative 3. When you punch in negative 5, you should get 0. When we punch in negative 2, we should get negative 3. And when I punch in, whoops, that should be negative 1. Negative 1, that should be 0 as well. Again, we have that symmetry, as long as you pick the 2 numbers directly before and the 2 numbers directly afterwards. Right? What would my y-intercept be for this one?
-4.
My y-intercept. Where's the y-intercept? What was it, Drew? Very good. 5. My y-intercept is just my c value. It's my y-intercept. So if I plot that 0, 1, 2, 3, 4, 5, boom, I can get another point. This is 3 away, 3 away. You can use that as well. All right. We pretend that it went through the dots. And there's our graph. Again, guys, use your calculator. Graph it. Check your table to make sure your values match. Make sure your graph matches it. All right, questions on that one? Okay, next up on your board, I want you to write the distance formula. Distance formula. Distance formula. What's a quadratic formula? Good. Distance formula. You're close, you're close. Check what's inside your parentheses. Katya, you're also very close. You need some squareds. Ooh, John, you're even closer. What's in between your parentheses? Beautiful. There. Natalie, you're close. I haven't seen very many more. I'm still waiting to see from a lot of you. Good, Jason. Gerard, did I get to see one from you? Ryan? Freddie, did you fix it yet so it's no longer quadratic formula? Actually, Gerardo, inside your parentheses should be minus. X minus. Alright. Okay, so distance formula, x minus x squared plus y minus y squared.
Oh.
Would you guys, which one do you want to do? Distance, midpoint, Pythagorean, graphing, or quadratic formula?
Homework.
Graphing distance.
Raise your hand for distance. Raise your hand for graphing. I'm sorry, Drew. It looks like we're doing distance.
Graphing.
All right.
Graphing.
You want to pick one of those?
I'm gonna borrow this.
All right, distance. Let's do this one. Find the distance between these 2 points: -3, -2, and 4, 1.
Either way, it doesn't matter actually, just as long as you're consistent with it.
Doesn't matter which point you start with, just as long as you're consistent.
And please come get help if you need to. You have me back here, ready and willing to work with you one-on-one.
Oh no, you're fine.
You get spread.
I'm trying to figure out what happened.
All right, I'm passing out your homework to you. Review for your test next class. The answer key is up on Blackboard, so make sure you check the answer key and come see us with questions before class begins. We'll also be collecting your notebooks next class, so make sure you have those.
Miss, can I come? I might come tomorrow after school.
Tomorrow is the last late bus day, so take advantage of that. You have your test on Friday, so come tomorrow so you can come see us for help before your test. This is your last big opportunity to help you raise your grade for fourth quarter. If you would please clear off your boards and return the return the markers, forests, and socks, and then we'll also trade back calculators.